Welcome to the History Maps podcast. You are tasked with building a skyscraper, but you have no steel, no reinforced concrete, no cranes, and definitely no modern mathematics.
Right, which sounds like an impossible prompt.
Completely impossible by today's standards. Your primary building materials are just quarried stone, sand, lime mortar, and timber. And to make it harder, you want the walls of this massive structure to be made almost entirely of glass.
A fragile material, obviously.
Exactly. You want the ceiling to vault over 100 feet into the air, and you need this entire edifice to withstand centuries of wind, rain, and shifting soil. So today, in our deep dive, we are exploring a technological and spiritual revolution that completely upended the fundamental logic of gravity. We're looking closely at the architectural era spanning from the 12th to the 16th century across Europe.
It is a massive shift in human engineering.
It really is. We are going to unpack exactly how medieval builders took heavy, dark, earthbound enclosures and transformed them into soaring, skeletal frameworks of light.
And to understand the mechanics of how these builders managed to turn solid stone into, well, basically lace, we first need to establish the baseline. We need to look at the 11th and early 12th centuries to see what these masons and architects were evolving away from.
Right, the before picture.
Exactly. Prior to the mid-12th century, major churches, abbeys, and cathedrals were constructed in what we call the Romanesque style. And the defining characteristic of Romanesque architecture is an absolute submission to gravity. The primary structural strategy was just sheer mass. You had massive, heavy masonry walls, incredibly thick profiles, and rounded arches.
So if you look at a Romanesque building, the primary feeling is one of immense defensive weight. It operates almost like a heavily fortified cavern. The architecture constantly reminds you of the earth, the sheer physical mass of the material.
Because the primary job of a wall in this era was very simple. It just had to hold up the roof, and that roof was typically a barrel vault.
Which is essentially a long stone tunnel, right?
Basically, yeah. You can picture a barrel vault as a continuous, elongated, rounded arch. Constructing a stone tunnel high in the air presents a severe physical challenge because all of that stone is immensely heavy. And because a rounded arch pushes its weight outward as well as downward, the walls supporting that ceiling had to be exceptionally thick.
Right, because if the walls were thin, the outward thrust of the stone ceiling would just push them over, and the entire structure would pancake to the ground.
Precisely. So consequently, because the walls were doing so much structural work, builders could only afford to pierce them with very small, deeply recessed windows. Any large opening would severely compromise the structural integrity of the entire wall.
So the interior of a Romanesque church is naturally going to be dim. You are enveloped in dark stone, lit mostly by candlelight and whatever natural light can squeeze through those tiny openings. It feels rooted, permanent, and fiercely protective.
But then a very specific shift occurs. The mold of that solid, heavy fortress is shattered, and it begins with a specific individual in a specific place.
Let's get into the origins then.
We turn our attention to Abbot Suger, who lived from 1081 to 1151. Now, Suger was not some humble monk quietly illuminating manuscripts in a remote cloister. He was a central power broker in France.
A major political player.
Very much so. He was the abbot of Saint-Denis, which was a royal monastery situated just north of Paris. But his influence extended way beyond the abbey walls. Suger was a crucial political force, serving as a trusted advisor to King Louis VI and subsequently to King Louis VII.
And his political power really cannot be overstated here. When King Louis VII departed for the Second Crusade between 1147 and 1150, he actually left the kingdom in Suger's hands.
Right. Suger acted as the regent of France.
He was overseeing the state, managing the treasury, and navigating all the complex feudal politics of the era. He had a level of authority and access to resources that very few individuals possessed at the time.
And Suger's political acumen and his theological vision intersected directly at his abbey church, the Basilica of Saint-Denis. The old structure of the basilica had been completed all the way back in 775 during the Carolingian era.
So it was ancient by that point.
Oh, absolutely. By the year 1137, it was severely dilapidated. It was too small to accommodate the crowds of pilgrims, and it was really showing its age. From Suger's perspective, this crumbling building was entirely unbefitting its status.
Because Saint-Denis was the church that held the relics of Saint-Denis, who is the patron saint of Paris.
Exactly. And crucially, it was also the traditional burial place of the French kings.
Right. So Suger looks at this small, aging, dark, Romanesque structure and decides it needs to project something entirely different. He initiates a massive rebuilding process, and the timeline is incredibly rapid when you consider the technology of the 12th century.
It's a very fast turnaround.
He begins on the west end of the church in 1137. He constructs a completely new facade, incorporating 2 towers and 3 massive, deeply recessed doors. Then, by 1140, he shifts his attention clear to the other side of the building, to the eastern end, and begins to rebuild the choir.
Which is the area surrounding and behind the main altar.
Right.
And that new choir was completed and consecrated in 1144. It is within this specific architectural space that we see the spark of the new style. Sugar documented his reasoning, his fundraising, and his theological goals in his writings, specifically a text known as the Book of Sugar.
He wrote it all down for us.
He did. He was profoundly influenced by theological texts that equated physical light with the divine presence. He wanted to create a physical manifestation of the divine on earth. He focused on the concept of divine light, the notion that material beauty and luminosity could elevate the human soul from the material world toward the immaterial divine realm.
He essentially tasks his masons with building a theology text out of stone. But I have to question his true motivations here. Sugar writes extensively about divine inspiration, claiming he was compelled to rebuild the church to avoid displeasing the holy martyrs.
Right, that's his stated reason.
But we just established that Sugar was effectively running the country. He was a fervent patriot and a highly calculated political operator. By building something so unprecedented, so structurally daring, and so expensive at the very site where French kings were buried, wasn't he simply cementing the political power of the French crown and his own personal legacy?
Well, you are applying a modern division between church and state that simply did not exist in the 12th century worldview. To a modern observer, we tend to parse out the political agenda from the religious rhetoric. But for Abbot Sugar, the best interests of the king, the state of France, the Abbey of Saint-Denis, and God were entirely inseparable.
They were one and the same to him.
Exactly. The French king ruled by divine right. Therefore, elevating the prestige of the French monarchy was doing the work of God. Creating a magnificent, luminous reliquary for Saint-Denis honored the patron saint, which in turn protected the kingdom of France, which ultimately glorified the divine.
So it's a loop.
Yes. The political calculation and the fervent religious belief were part of a unified continuum. The architecture he pioneered was engineered to project royal authority and divine grace simultaneously.
So he wanted space, and he wanted light. But you run into a severe physics problem the moment you try to build a wall out of glass. You cannot have a wall of glass if that same wall is tasked with holding up thousands of tons of stone ceiling.
The physics just don't allow for it.
Right. The traditional Romanesque wall had to be thick to carry the load. So to achieve Sugar's vision, the builders had to rethink how gravity interacts with masonry entirely. Which brings us to the structural trinity of Gothic design.
The 3 big innovations.
Yes, there are 3 distinct engineering features that, when combined, made this architectural leap possible. Let's start with the first core feature, which is the pointed arch.
The pointed arch is the most immediate visual identifier of the style, but its primary value is strictly structural. To understand its efficiency, we must contrast it with the Romanesque rounded arch. When heavy stone is piled on top of a semicircular arch, the physics of that shape push the weight outward as well as downward.
It spreads out.
Exactly. It creates lateral thrust. The rounded arch naturally wants to flatten out under pressure. The only way to stop a rounded arch from pancaking and pushing the supporting walls outward until they collapse is to build massive, incredibly thick masonry walls to absorb that horizontal force.
So think of a rounded arch, like someone doing a wide split on a highly polished floor. The weight of their body is pushing down, but their feet are constantly wanting to slide outward, away from each other. That horizontal sliding motion is the lateral thrust. It takes a massive amount of bracing or incredible friction to keep them from falling flat.
That's a good way to picture it.
But the pointed arch is like someone standing tall, with their feet planted firmly together. The weight of their body is driven straight down through their legs, directly into the floor. Because the pointed arch meets at a steep peak, it directs the weight of the masonry above it downward in a much more vertical trajectory.
And the mechanics back up that visualization perfectly. Because the pointed arch directs the thrust downward rather than outward, it requires significantly less lateral mass to keep it stable. The walls no longer need to be massive, thick fortresses to counter an outward push.
It's so much more efficient.
It is. Furthermore, a pointed arch can be built much taller without having to widen the base. A semicircular arch is strictly bound by its radius. To make it taller, you must make it wider. A pointed arch frees the builder from that geometric constraint, solving the problem of elevation and efficiency at the exact same time.
Which leads directly into the second core feature of the Trinity, the ribbed vault. So builders took these highly efficient pointed arches and used them to completely redesign the ceiling itself.
Right, they moved away from the tunnel shape.
Instead of the heavy, continuous tunnel of a Romanesque barrel vault, they built a framework of intersecting arches. They laid down diagonal and transverse stone ribs that crossed each other over the open space of the nave.
And what they created was a load-bearing structural skeleton. In a traditional Romanesque vault, the entire ceiling is structural. Every inch of that thick stone surface is bearing weight and transmitting thrust. But with the rib vault, the intersecting stone ribs carry the vast majority of the weight.
So the ribs are doing the heavy lifting.
Yes. Once the ribs are locked in place, the builders install stone panels between them. This infill is relatively thin and light. It does not carry the primary load. This skeletal framework concentrates the massive weight of the ceiling down into very specific, isolated points at the corners of the vault, rather than pressing down evenly along the entire continuous length of the wall.
So the heavy lifting is being done by a stone skeleton, not a solid stone shell. But even with the vertical efficiency of the pointed arch and the targeted weight distribution of the ribbed vault, you are still suspending an enormous amount of stone very, very high in the air.
There is still weight to manage.
Right. As builders pushed these structures taller and taller, there was still a significant amount of outward thrust that needed to be managed. You still have forces pushing outward on the upper walls. This requires the third and arguably most dramatic feature of the structure, the flying buttress.
The flying buttress is an external, bridge-like support system. If you look at the exterior of a mature Gothic cathedral, you will see heavy stone piers or towers standing completely unattached from the main walls.
Just out there in the open air.
Exactly. From these freestanding external towers, an arched bridge of stone reaches across the open air and presses directly against the upper exterior wall of the church's nave. It connects exactly at the critical point where the interior vaults are pushing outward. The flying buttress catches that remaining lateral thrust from the ceiling and transfers it safely down the external tower and into the ground.
Structurally, it is brilliant. But from a purely visual perspective, it's entirely unintuitive. Why would builders take the most vital structural supports, the very legs holding the building up, and put them on the outside, completely exposed to the rain, the wind, and the elements?
It seems unintuitive until you factor in the primary mission we talked about earlier, the pursuit of light. By moving the heavy, load-bearing structures to the exterior, by creating this massive stone exoskeleton, they completely liberated the interior walls.
They freed them up.
The interior walls were no longer the primary support system for the building. They were stripped of their load-bearing duty. The walls between the structural piers could suddenly become incredibly thin. They essentially transitioned from structural barriers into thin stone screens.
And a thin, non-load-bearing screen can be entirely pierced and opened up.
Precisely. The flying buttress is the crucial innovation that allows the solid stone wall to vanish, replaced by luminous expanses of color.
Okay, so the engineering puzzle is solved. The pointed arches, ribbed vaults, and the exoskeleton of flying buttresses have successfully diverted the forces of gravity. The heavy stone is pushed out of the way. You now have vast, empty wall space where solid masonry used to be. So the focus shifts to what they filled that empty space with and how it affected the people who actually walked inside.
The shift is profound. The building changes from a sealed stone container into a framework for light. The vast, empty spaces between the piers were filled with intricate tracery.
Which is the stonework holding the glass, right?
Yes. Tracery refers to the delicate branching stone outlines that divide the large window openings. This masonry web was absolutely necessary to support the massive banks of stained glass. The tracery holds the individual panes of colored glass in place against the pressure of the wind, while still maximizing the amount of light entering the space.
And the visual effect of this stained glass was unprecedented. It wasn't simply illumination. It was colored, vibrating light that shifted and transformed the interior atmosphere continuously throughout the day.
A key feature of this glazing was the rose window. This is a massive, highly complex circular window, typically placed on the western elevation, right above the main entrance portals. As the sun sets in the west, it beams directly through this kaleidoscopic circle of glass, casting complex patterns of colored light all the way down the length of the nave.
But we have to remember the highly functional purpose behind all of this imagery. Medieval populations were largely illiterate. They did not possess personal texts they could read at home. The architecture itself, the extensive stone sculptures, and the intricate scenes depicted in the stained glass were the primary source of historical, moral, and biblical knowledge for the vast majority of people.
The building functioned as a visual textbook and a cultural record. Every pane of glass, every statue surrounding the doorways, every carved capital on a column was engineered to teach a specific lesson, tell a specific story from Scripture, or detail the lives of the saints.
It's all purposeful.
Right down to the outside. The decoration extended to the exterior in highly symbolic ways. We see the extensive use of gargoyles. Practically, gargoyles function as water spouts. They throw rainwater clear of the walls to prevent the mortar from eroding.
But visually, they are often carved as grotesque, mystic animals or demons.
Yes, they told religious stories too, representing evil forces that are kept firmly on the outside of the sacred space. They served as strict warnings to the faithful passing below.
And the entire exterior profile of the building was engineered for psychological impact. You have towering spires, which are elongated, sharp, pointed structures reaching up for the towers. You have pinnacles, which are ornamental, cone-like caps placed on top of the flying buttresses and smaller towers.
Every element has an upward thrust.
Every single line, both inside and out, from the vertical pole of the interior piers to the exterior spires, is meant to draw the eye forcefully upward toward the heavens.
The psychological intent was carefully calibrated by the architects and the clergy. The architecture was designed to strike the viewer with a specific, overwhelming mixture of emotions: fear, awe, and humbleness.
Picture a medieval peasant.
Right, someone who spent their entire life in a small, low-slung, dark timber dwelling, walking through the massive western doors of a structure like Amiens Cathedral. The sensory overload was absolute. The sheer scale, the reverberating acoustics, the deeply colored light, the towering height, it all combined to make the individual feel infinitesimally small in the face of the divine.
The structural perfection and the defiance of gravity were presented as a direct reflection of God's kingdom manifested on earth. So now that we have established the structural toolkit and the spiritual goals, we need to trace how this style actually evolved over time.
It didn't happen all at once.
No. The style initially emerged in northern France, specifically in the Ile-de-France and Picardy regions. And during the 12th and 13th centuries, builders did not call this Gothic. It was known widely as opus franciginum, which translates to French work.
The defining characteristic of this original French work is a relentless, almost obsessive drive for verticality. The French builders were constantly locked in a competition to push the limits of height.
Breaking records.
Always. To complement this vertical thrust, the roofs are high-pitched and exceedingly steep. The sightlines are dominated by numerous soaring spires. In their floor plans, the transept projections, the horizontal arms of the cross shape that intersect the main nave are often kept very slight or sometimes neglected almost entirely.
Which keeps the visual focus on the unbroken vertical and longitudinal lines.
Yes. The plans typically incorporate multiple side chapels radiating out from the eastern choir. And the western elevation, the main entrance facade, is highly formalized, usually anchored by two massive, prominent towers.
But developing this complex structural system involved serious growing pains. In the early stages of French Gothic design, builders often relied on thick, circular Romanesque columns to support the new ribbed vaults.
It was a transitional period.
Yeah, if you examine early structures, you can see very awkward aesthetic and structural joints where the complex, multi-layered stone ribs of the ceiling drop down and meet the simple, flat capital of a round, heavy column.
It took time for masons to develop clustered piers. Those are columns made of multiple attached shafts that seamlessly carry the lines of the ceiling ribs all the way down to the floor. The evolution of the style within France was rapid, though, and we can track it through key examples.
Like Chartres Cathedral.
Right. Begun in 1194, which is frequently cited as the benchmark for the mature High Gothic style. Then you have Amiens Cathedral, begun in 1220, which pushed the limits of the engineering, boasting interior naves that soar well over 100 feet tall.
Incredible heights.
And there is Reims Cathedral, the traditional coronation site of French kings, which showcases incredibly complex exterior sculpture and deeply recessed entrance portals.
We also have to look closely at Notre Dame de Paris. Construction started on Notre Dame in 1163. What makes this cathedral so compelling is that it operates as a living document of continuous modification.
It wasn't built overnight.
It was built, altered, expanded, and restored over centuries, reflecting new liturgical needs and changing aesthetic tastes. It has been a central fixture of French identity. Following the devastating fire in 2019, the structural integrity of those medieval vaults was severely tested.
And the world watched.
As it underwent a massive, painstaking restoration process, reopening its doors to the public on December 8, 2024, it proves how enduring and resilient these stone skeletons actually are.
Historians generally categorize the evolution of the style within France into four distinct phases. The first is early Gothic, roughly from 1130 to 1200.
Okay, so that's the experimental phase.
Exactly. This phase is characterized by experimental rib vaults, walls that are still somewhat thick to manage the untested loads, and the transitional use of round columns we talked about earlier. The second phase is High Gothic, from 1200 to 1250. This is where the engineering system reaches maturity.
Everything slims down.
Yes, the supports become much slimmer, the flying buttresses are fully integrated into the exterior design, and the clerestory windows, the highest level of windows in the nave, expand massively as the builders trust the exterior buttresses to carry the weight.
The third phase is Rayonnant Gothic, spanning from 1230 to 1350. Once the primary structural challenges of height and weight had largely been solved, the builders shifted their focus. This phase is defined by an absolute obsession with light and fine, linear tracery. They worked to turn the remaining walls into the most delicate, glass-filled webs physically possible.
Pushing the glass to the absolute limit.
And finally, we have late or flamboyant Gothic, from 1350 to 1550. The term flamboyant refers to the flowing, flame-like, incredibly elaborate decorative tracery that dominates this period. The underlying structural logic remains exactly the same, but it is heavily overlaid with intricate, almost organic stone decoration.
Those four phases map the maturation of the technology in its homeland of France. But the true test of any architectural revolution is what happens when it is exported.
Right, when it leaves home.
Exactly. What happens when this highly specialized French architectural technology crosses borders and encounters different climates, different cultural tastes, and entirely different historical roots? This shift brings us to the regional interpretations of the style, beginning with England.
The English adopted the basic vocabulary of the Gothic style, but they fundamentally changed its priorities. If the French blueprint was defined by a relentless drive for verticality, pushing the vaults higher and higher into the air, the English approach was defined by a drive for horizontal expansion.
They wanted length, not just height.
The English pushed for length. The shift in proportion is immediately noticeable when you enter an English cathedral. They feature incredibly long, narrow floor plans.
Rather than prioritizing a towering central nave, the English often utilized a much lower roofing profile. The eastern ends of the churches, the apses, are frequently square, as opposed to the rounded or polygonal apses that are common in France.
And their transepts are different too.
Yeah, they also frequently employed double transepts, creating a much more complex, sprawling, cross-shaped footprint. Visually, the exterior massing is anchored completely differently.
How so?
Well, while the French emphasized the western facade with massive twin towers and a prominent rose window, the English largely de-emphasized the western entrance. Instead, they focused their vertical energy on a single, extremely high central tower placed over the main crossing of the nave and transept.
And because they were not building the main walls as high, the English builders did not rely as heavily on the dramatic, sweeping, flying buttresses that define the French exterior. But what they lacked in sheer height, they made up for by looking upward and absolutely obsessing over the complexity of the ceiling.
The vaults become incredibly intricate.
The English took the basic ribbed vault and elaborated on it to an astonishing degree. They began adding extra stone ribs that served no structural purpose. They were added purely for geometric complexity. They added intermediate ribs, Lyran ribs, and stellar ribs, which create incredibly complex star patterns across the entire span of the ceiling.
This deep fascination with vaulting complexity culminates during the late perpendicular phase, spanning from the 14th to the 16th century. In this phase, English masons developed the fan vault.
The fan vault is visually distinct.
Very distinct. In a fan vault, the ribs fan out equally from the top of a pillar, creating a highly intricate, cone-like geometry that covers the entire ceiling in a web of delicate stone lace. You can see this vividly in structures like Gloucester Cathedral.
So while the French focused their resources on breaking height records, the English focused on dispersing visual interest along the entire, immense length of the building, turning the ceiling itself into a mesmerizing geometric canvas. Key examples of this uniquely English approach include Salisbury Cathedral, Ely Cathedral, and Westminster Abbey.
Now let's look at a completely different reaction. If the English modified the style to suit their specific tastes, the Italians essentially resisted the core tenets of the style entirely.
They weren't fans.
Not really. Italian Gothic architecture represents a group of very reluctant adopters. A major reason for this reluctance comes down to simple climate and geography.
Right, the environment dictates the building.
The Italian climate dictated a completely different approach to the treatment of the wall. The entire premise of French Gothic is to dissolve the solid wall to let in as much light as possible. But in the daily, intense sunshine of the Italian peninsula, large, unshaded glass windows would turn a stone church into an unbearable greenhouse.
Yeah, it would be sweltering inside.
Exactly. Therefore, the Italians deliberately kept their window openings relatively small, maintaining thick, solid walls to keep the interiors cool and shaded. Furthermore, Italy was surrounded by the physical ruins and the enduring cultural influence of Roman and Byzantine architecture.
They had a different historical baseline.
Yes. The Roman architectural spirit prioritized mass, solidity, and the creation of one great unified central space. The French Gothic approach of creating a fragmented, skeletal framework divided by massive piers fundamentally clashed with the established Italian aesthetic sensibility.
So how did the Italians adapt this French work when they did incorporate it? The visual result is striking. Instead of focusing on soaring, skeletal stonework, the Italians focused heavily on the surface treatment of those thick, necessary walls.
They used their local materials.
They utilized high-quality materials, applying colored Italian marble veneer directly over brick structures. They heavily favored alternating patterns of black and white marble to create visual rhythm, rather than relying on the structural rhythm of vertical piers and pointed arches.
The walls became canvases.
Exactly. They extensively utilized brilliant mosaics and large-scale interior frescoes, which required vast expanses of solid wall space to act as a canvas. On the exterior, the elevations remained mostly flat because they often attached the buttresses directly to the solid walls rather than using the dramatically detached flying buttresses. It is a completely different aesthetic, utilizing only select elements of the pointed arch technology.
The environmental constraints that shaped Italian architecture bring us to another dramatic regional adaptation. When you move away from the marble quarries of Italy and the limestone deposits of France, and you enter the harsh realities of the Baltic Sea region, geography dictates a completely different material approach.
What do they use instead?
This constraint led to the creation of brick Gothic, or Backsteingotik. The Baltic region, specifically the areas dominated by the wealthy trading cities of the Hanseatic League, faced a major material shortage.
They lacked limestone.
They lacked workable granite, too. Trying to carve delicate tracery or soaring piers out of the local stone was virtually impossible, but what they did have in absolute abundance was clay.
So they turned to brick.
The abundance of clay meant they had to rely on the ancient art of brickmaking. The specific technique of baking red bricks was imported into the Baltic Sea region from Italy in the 12th century. This material necessity birthed an entirely unique aesthetic.
Because builders were utilizing serial production of shaped clay blocks, they could produce identical modular pieces on a massive scale.
Yes, it was standardized.
The architecture is defined by the rough, textured surfaces of the fired clay and the warm, intense red glow of the material. Because a standard brick cannot easily be carved into the delicate, lacy forms of French stone tracery, brick Gothic structures tend to be more massive, with bolder, heavier forms. The builders relied on the pattern and texture of the brickwork itself to provide the primary decoration.
What stands out about brick Gothic is that it was heavily driven by civic pride, not just ecclesiastical ambition.
It wasn't just for churches.
No, the builders certainly constructed massive brick churches like the Marienkirche in Rostock or the Petrikirche in Hamburg, but this style heavily defined secular power as well. The Hanseatic League cities were incredibly wealthy, independent trading hubs.
The merchant class had money to spend.
And they used it. The merchant class used the brick Gothic style to build massive town halls, imposing town gates, and towering merchant houses in cities like Bremen, Stralsund, Lübeck, and Tallinn. It was an architecture of commerce and civic independence as much as it was an architecture of faith.
That expansion into the secular world forces us to broaden the lens. It reveals how Gothic architectural technology infiltrated daily medieval life and eventually evolved beyond its specific era. Gothic design was not reserved exclusively for cathedrals.
It spread everywhere.
As the Middle Ages progressed, The structural logic and the aesthetic vocabulary of the pointed arch and the ribbed vault were applied widely across the built environment. You see the style adapted in the rapid expansion of universities and colleges across Europe. You see it in guild halls, where trade organizations displayed their wealth and influence. You see it in the design of royal palaces.
There is also a distinct societal shift reflected in domestic architecture during this period. As the era became slightly more stable, you see a movement away from the heavy, purely defensive castles of the Romanesque period.
People wanted comfort.
Right. The wealthy began building fortified houses that were designed for comfort and display, often utilizing elaborate timber frames that incorporated Gothic arches and decorative motifs carved directly into the wood. The style permeated the entire landscape.
But eventually, every architectural era faces a cultural backlash. As Europe transitioned into the 16th century, the cultural pendulum swung violently backward toward classical antiquity.
Enter the Renaissance.
Yes, the Renaissance scholars in Italy, men like Giorgio Vasari, looked back at the soaring, skeletal, asymmetrical structures of the previous centuries with utter disdain. They were obsessed with reviving the pure geometry, proportion, and solid masonry of ancient Rome and Greece.
And this cultural shift is exactly where the term itself originates.
Really?
Yes. The medieval builders who constructed these structures never once called them Gothic. The term was coined strictly as a pejorative insult by those Renaissance scholars. To scholars like Vasari, this pointed, spiky, rule-breaking style was monstrous and barbaric.
They meant it as an insult.
Entirely. They equated the architecture to the Goth tribes, the very barbarians who had sacked the Roman Empire centuries earlier. Calling a building Gothic was a deliberate way of dismissing it as uncultured and ruinous to the classical ideal.
It is a profound historical irony that a term meant as a severe insult became the universally accepted label for one of the most sophisticated engineering achievements in human history.
It really is. And despite the Renaissance backlash, the style refused to die completely. It endured in various modified forms and then experienced a massive resurrection during the 19th century.
We see this clearly with the Gothic revival.
The Victorian neo-Gothic movement saw architects actively resurrecting the medieval vocabulary for entirely new cultural purposes. When you look at the Houses of Parliament in London, built in the 19th century, you are looking at neo-Gothic architecture.
Right in the middle of the Industrial Age.
Exactly. In the midst of the Industrial Age, reviving the Gothic style was often a deliberate choice, meant to evoke a sense of lost morality, deep romanticism, and historical memory. Architects and theorists utilize the visual language of faith and medieval craftsmanship as a direct antidote to the perceived soullessness and mechanization of the Industrial Revolution.
This gives us a completely new lens to view these structures through. It is easy to walk up to a Gothic cathedral today, point your camera, and view it simply as a static historical artifact, a pretty piece of old masonry from a bygone era.
But they were so much more than that.
We have to remember what these buildings actually represented. For the people of the 12th through the 15th centuries, these were not static artifacts. They were highly functioning cutting-edge technologies. They were precise machines engineered for manipulating light and gravity.
And they communicated complex ideas to the masses.
And, perhaps most importantly, they were the first mass communication devices designed to physically overwhelm the human senses and present an absolute, undeniable argument for the divine.
They represent a specific moment in time where engineering, politics, and theology fused together so completely that you cannot separate the physical structure from the belief system that demanded it to be built.
Thank you for listening. History Maps. Learn history visually.